All right, let's talk some more about graphing linear equations in two variables. So first thing we're going to do, it's a little bit of review from what we did in 3.1. But for this first set of examples, let's go ahead and complete the ordered pairs for a specific equation. And that equation is x plus 2y equals 7. And we're reviewing these because this is what we're first going to be doing when we start graphing linear equations, and then we'll go ahead and look at some shortcuts in the next few sections. So number one, we're given the point -1, blank. And so we want to figure out what this blank is. So remember, we need to figure out what we're given, what we're looking for. Any type of problem you're looking at, it's always good to figure out what you're given first, because that's what's going to tell you how to find the rest of the problem, whatever's missing. So we're given the x, looking for the y, which means we can plug in -1 for x. So we have -1 plus 2y, don't know what y is, equals 7. And then all we have to do is solve for y, so variable terms on the left already, so let's add this one to the right. And we get 2y equals 8. Divide both sides by 2. Hopefully solving these equations is getting a little bit easier now. And we get y equals 4. So this is our first missing number here, which means that this point here, this -1, 4, is on this line. So now if we can go ahead and find a second point, which is number 2, we're given 7, blank. For this one, we wanted to go ahead and do the same thing. And this is going to give us another point on the line. And once you have 2 points, you can graph a line. So let's go ahead and, again, we're given the x, looking for the y. So plug in x, 7 plus 2y equals 7. Let's do the same thing and subtract 7 from both sides. So we get 2y equals 7 minus 7 is 0. We can't just cancel them, we actually have to put 0 there. And divide both sides by 2. So we get y equals 0 divided by any number is 0. So we have a line here where we have the point -1, 4 and 7, 0. And if we were to plot those points and connect them, we have the graph of this linear equation here. And so let's go ahead and write down just kind of what the graph of these should always look like. So the graph of a linear equation, and this is just what it sounds like, because it's a linear equation, is a straight line. So if you're ever graphing these, you plot some points and you have some that are kind of, there's 2 in a row, and then you have one that's kind of off to the side. You know one of these has to be right, or sorry, one of them has to be wrong, because we could have a line that's going through this way, or we could have a line that's connecting these two, or even these two. And so there's 3 different options here. And so we know there's only one way to graph these lines. So you want to double check your points and make sure that you plot them all correctly or did your math correctly. All right, so let's go ahead and look at some examples where we start graphing. So for this example here, we want to graph by plotting points. And so not number one, only one here, we're given, actually we do have 2 different examples here, sorry. Number 1, we're given the equation x plus y equals 6. And we're also given the table that's partially filled out with x on the left, y on the right, 0 for x, 0 for y, 4 for x. And so for this one, we want to fill in this chart. And so normally, if you were just given the equation, you only need to find 2 points. This one, they want us to find all 3, so let's go ahead and do that. So remember, we want to plug each of these values in separately and figure out the missing points. So if we plug in 0 for x, we get 0 plus y equals 6. 0 plus y is just y equals 6. Super nice one there. We go ahead and just put 6 in for that y coordinate. Now let's go ahead and do the same thing for the y coordinate of 0. So if we do that, we have x plus 0 equals 6. X plus 0 is x equals 6. We get the same thing, but now that's our x coordinate. And now let's go ahead and do the last one. Plug in 4 for x. I'll go ahead and just do this down here. 4 plus y equals 6. Subtract 4 from both sides, and we get y equals 2. All right, so now let's go ahead and try graphing this one. See if I can get, what is this guy? No, not that one. All right, let's go ahead and set up our axes. So we have our y-axis, our x-axis, and then I'll go ahead and just do the rest by hand. So you want to see how far out we want to go on the x and the y-axis. And that, I'm just going to fix that really fast. That is extremely crooked. I'm not looking straight at my laptop. So let's go down and across. A little bit better. So if you notice, we go 6 up in the y, 6 to the right in x, and then 4 and 2. But there are no negative numbers, so it doesn't actually matter how far left or down we go. But I'm going to go ahead and just go 6 in each direction. So we have 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5, 6, negative 6. And then up 1, 2, 3, 4, 5, 6. So our y-axis, x-axis, and down 1, 2, 3, 4, 5, 6. If you have graph paper, I definitely recommend graphing on graph paper while you're taking your notes. It's going to make your graphs look a little bit nicer. So our first point here is 0, 6. So remember, this 0 means left or right 0, and then we want to go up 6. So start in the origin, left or right 0, up 6. The second point here means we want to go right 6, up or down 0. So right 6, up or down 0, we're right there. And then finally, this last point, 4, 2 means right 4, up 2. So right 1, 2, 3, 4, up 2, roughly goes right there. And so all of these should be in a line. And they are for the most part. And so for these ones, make sure that you have your arrows on the ends. It doesn't stop at these points. There's an infinite number of points we could pick. We could have plugged in 1,000,000 and we would still get a point. It would just be way down here. And so make sure you have those arrows on the end. But this is our graph of x plus y equals 6. All right, let's go ahead and try another one. Number 2. 2x minus 4y equals 8. And so this one, we're not given a chart. So that means that we're free to pick whatever numbers we want to plug in. 2 of them are really nice, and these are ones that we'll see in a second. So if we go ahead and let's just say we pick x equals 0. And we want to figure out what the y is. We can do this, and then we can pick one other point, but you only need 2 points to make a line. If you want to do more, that's a really good way to kind of double check that your arithmetic was good, because these 2 points, if you plot them wrong, or if you plugged in and simplified wrong, you can't tell if they're wrong when you look at the graph, because your 2 points will always make a line. So having a third point is good to just kind of double check that. But I'm going to go ahead and pick 0, and then I'm going to pick, let's say, 1 for x. We could have picked any other number for x. I like to just keep them small. And it's also, well, you can pick an x or you could pick a y. So we could have also plugged in 1 for y if we wanted. So let's go ahead and plug those guys in. So plugging in 0 for x, we get 2 times 0 minus 4y equals 8. 2 times 0 is 0, minus 4y equals 8. 0 minus 4y, negative 4y, equals 8. And then if we go ahead and divide both sides by negative 4, we get y equals negative 2. So that is our first y coordinate there. And now if we go ahead and plug in the 1, we get 2 times 1 minus 4y equals 8. 2 times 1 is 2, minus 4y equals 8. Subtract the 2, and we get negative 4y equals 6. And now if you notice here, when we divide both sides by negative 4, we get y equals 4 doesn't go into 6 evenly. So I'm going to go ahead and just reduce this and then change it to a mixed number so it's easier to graph. So this will be negative 3 over 2, which is the same thing as negative 1.5. So sometimes you will get fractions for these. If you don't want to work with this fraction, you could just plug in another number. You could plug in 2 instead, and 2 would actually give you a nice whole number. But let's go ahead and go with this one because sometimes you will be graphing fractions. So let's go ahead and graph this one. So we'll draw our vertical line here, or horizontal line across here. And then let's go ahead and label our axes. So we have x and we have y. And if you notice, we do go into the negatives, but the highest we go is 2 in any of these. So I'm going to go ahead and just go out to, let's go out to 3. And these ones are a little bit more spaced out. That's negative 3, that's 2, or sorry, that's positive 3. And we can go up 1, 2, 3, down 1, 2, 3. And now if we go ahead and graph, 0, negative 2, left to right 0, down 2. So left to right 0, down 2. And then 1, negative 1.5 means right 1, down 1.5. So right 1, down 1.5. So it should be halfway between negative 1 and negative 2. All right, so we have our line. Goes roughly through these 2 points here, and it goes on forever in each direction. Oops. Drawing random lines here. There we go. All right, so now let's go ahead and graph in a slightly different way. We're going to graph using something called intercepts. So let's first look at how we find intercepts. I'm all over the place today. Finding intercepts. So for finding intercepts, let's first talk about what intercepts are. So let's say that we had this really roughly drawn graph here. We have our x and our y-axis. And let's say we have this line that goes down to the right like this. The intercepts are where it intersects the x and the y-axis. So this point here is the x-intercept, because it crosses the x-axis. And this point here is the y-intercept, because it crosses the y-axis there. And so in general, our y-intercept, since it's always going to be on the y-axis, our x-coordinate will always be 0 because we haven't gone left or right at all. But we could have gone anywhere up and down. So it's going to be the point 0 for x, then whatever the y-coordinate is. And so in order to find the y-intercept, since we know x is always 0, we can plug in x equals 0 and then solve for y. And then the x-intercept is just going to be the opposite of that. So if we look at our x-intercept on the graph, all the way along the x-axis, our y is 0 because we haven't gone up or down, we've just gone left or right. So our x-intercept could be any number, but the y has to be 0. And so to find it given an equation, we're going to plug in y equals 0 and then solve for x. All right, so let's go ahead and take a look at a couple of examples. For these ones, we're gonna graph it by plotting the intercepts. And these ones are actually really nice to do because you're plugging in zeros. And so things are just gonna cancel out nicely and make solving really easy. So let's graph by plotting intercepts. Number 1, we're given 5x plus 2y equals 10. And so it doesn't matter which one we do first. Let's go ahead and plug in 0 for x first, which means we're looking for the y-intercept. So if we plug in x equals 0, we have 5 times 0 plus 2y equals 10. 5 times 0 is 0. And so we don't care about this term anymore. So I'm just going to cross that one out, and we're left with 2y equals 10. Divide both sides by 2, and we get y equals 5, which means that our y-intercept is the point 0, 5. And this is really important to note that when we're finding the intercepts, we're writing these as 2 separate points. One really common thing to do is put the y-intercept and the x-intercept in a single point, but they're not a single point, they're 2 separate points. So be careful when you're finding these and writing them out. All right, let's go ahead and find the x-intercept, plugging in y equals 0. So 5x plus 2 times 0 equals 10. 2 times 0 is 0, that goes away. So we're left with 5x equals 10. Divide both sides by 5. And we get x equals 2. So our x-intercept is 2, 0. And so now if we go ahead and graph these, let's go ahead and look at our points. We have 0, 5, and 2, 0. The biggest one is 5, so I'll go ahead and just go out to 5. That's our y-coordinate, so I'll go up 5. And then I'll go down however many fits because we don't have any negatives, so this doesn't really matter. I'll go down to -4. we only have an x coordinate of 2. So I'll just go out to 4, and then I'll go left 4, so -4. And if I plot our points, this is the y-intercept, 0, 5. So that means we're going through the y-axis at 5. And our x-intercept is 2, meaning we're going through the x-axis at 2. And then we can go ahead and connect these guys. And there we have it. It's our line graphed using the intercepts. All right, let's go ahead and try another one of these. Y equals 2/3 x minus 2. And so for this one, let's go ahead and do the same thing. We want to plug in x equals 0. And we want to plug in y equals 0. And so let's go ahead and do x equals 0 first. So we have y equals 2/3 times 0 minus 2. 2/3 times 0 is 0. This term kind of disappears, and we're left with -2. And so now we're done solving. So we have our y-intercept is the point 0, -2. And if we plug in y equals 0, we get 0 equals 2/3 x minus 2. A little bit uglier to solve. We need to get this x by itself. So I'll add 2 to both sides. So we get 2 equals 2/3 x. And then remember, to get rid of a fraction, we want to multiply by the reciprocal. So multiply by 3/2. And on the right side, these guys cancel, we get x. And then 3/2 times 2/1, the 2's cancel, and we get 3/1, which is just 3. So this means our x-intercept is the point 3, 0. And we can go ahead and graph this one. And our largest number is 3 in the x direction, 2 in the y. So we'll go out to 3 on each side. We'll do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Kind of roughly drawn here. But as long as you have them equally spaced, it doesn't really matter what the tick marks look like. Oh, forgot to label the axes in these. Let's go ahead and do that. All right, so now our y-intercept here is 0, -2. So left, right, 0, down 2. And our x-intercept is the point 3, 0. So right 3, up or down 0, right 3, up or down 0. And we can go ahead and draw our line through those points. And there we go. All right. So there is our second line. And let's try one more because this one's a little different. So number 3. We're given the equation 2x minus y equals 0. And so if we go ahead and, still plotting by the intercepts, plug in x equals 0, and then we'll plug in y equals 0. X equals 0 gives us 2 times 0 minus y equals 0. 2 times 0 is 0. That's gone. So we're left with -y equals 0. And then you can either think of this as dividing by -1 to get that y, or remember our trick with changing the signs. If you change the sign on the left, change the sign on the right, but 0, there is no opposite. So it's still just going to be 0. So our first intercept here is the point 0, 0. which is the origin. So let's go ahead and do the same thing with the y. We have 2x minus 0 equals 0. Subtracting 0 is not going to change this, so we have 2x equals 0. Divide both sides by 2, and we get x equals 0 divided by 2 is still 0. So now we have the point 0, 0 as well for our second intercept, which just means that the x and the y intercepts are exactly the same. They're both the origin. And so we can't plot a line or graph a line with one point. So we do need to find another one that's not one of the intercepts. So I'll just go ahead and plug in, let's just plug in x equals 2. Doesn't really matter what we pick, just if you can, try to keep the numbers small, that way you're not graphing like 10 on a number line when the rest of your points are at 0. So I picked 2. If I go ahead and plug that in, we get 2 times 2 minus y equals 0. 2 times 2 is 4 minus y equals 0. And then we can do one of two things. I can move this 4 over. And so just thinking ahead a little bit, that's going to make our y still be negative. But if I add the y over to the right, then the y will become positive and we'll be done solving. So I'm actually going to add that y over to the right. The other way still works, you just have to change your signs. So we get 4 equals y. And so we have the point 2, 4. All right, let's graph this one. So we have 4 is our largest coordinate here, and that's our y coordinate. So let's make sure we go up 4. And then I'll just go, we'll go 4 in each direction. So -4, 4, -4, 4, x-axis, y-axis. So we're going through the point 0, 0, that's our origin. And then the point 2, 4 means we go right 2, up 4. And graphing our line through those 2 points, we get this line that goes up to the right. All right, now let's go ahead and look at a couple of special cases. And so these ones, if you remember what kind of line it's going to be, they're going to be really fast. So just a little bit of memorization or thinking about what this equation means. So one of our special cases is when we just have y equals some number. So for example, if we were just given y equals 4, this means, go ahead and sketch out a little graph here. This means that y always equals 4. So if I went up to 4 on this y-axis here, I can't go up or down anymore, but I can go left or right. So it can be any point along this horizontal line. And so whenever you have this special case y equals some number, it's always going to be a horizontal line through y equals c. So whatever that number is. So if this one was 4, it goes through 4. If it was y equals -2, it would be down here. All right, and the other special case is x equals c. So x equals some number. And this one is saying that x is always equal to whatever number we're looking at. So for example, we're looking at x equals 2. This is saying that x always equals 2. So if I pick one point here where x equals 2, I can't go left or right, but I could go up or down because then our x value is not changing. So it's going to be anywhere along this vertical line. So this one is going to be a vertical line through x equals whatever that number is. All right, so special cases, if it's just an x or y, or it's always horizontal or vertical, just have to try to figure out which one. All right, so let's go ahead and look at just a couple of examples here. And then we'll take a look at a couple of application problems. In the textbook. All right, so for these examples, we want to graph y equals -5. And then number 2, go ahead and put it down here, we'll graph x plus 4 equals 6. So go ahead and try graphing that first one. Try not to look at your notes on what it should be, vertical or horizontal. But what we're gonna do, because it's y equals -5, it's just a y. That means that our y can't change from -5. So it could be down, if I label this as -5, it could be right here. We could go left or right, but we can't go up or down. So it has to be a horizontal line through -5. And now if we go ahead and do the same thing with our second one here, this one looks different because we don't have just an x by itself on one side, but we do have just an x, there's no y, so we know it has to be one of our special cases. And so in order to graph these, we always want that x or y by itself. So I'm going to subtract 4, so we get x equals 2. And now we can go ahead and graph this one. So again, let's set up our axes. X equals 2, it's gonna go through 2 on the x-axis. It can't go left or right because that would change our x, but it can go up or down. So it has to be a vertical line through x equals 2. All right, so that's it for graphing by plotting points. We're going to graph these again in section 3.3 and 3.4 by using slope and the y-intercept. But the last part of this section is an application. So let me go ahead and pull that up on my MATLAB. So this is going to be figure 16 on page 235. So before we get into that, take a look at that application over there. Let me just write down the questions and then we can take a look at it. So this application, like I said, this is figure 16 on page 235. And so number 1, we want to approximate the credit card debt in 2012. And then number 2, use the graph and the equation to find the year when the debt was about $2,800 billion. And then we're told to round down on this one. And for number 1, we're told to use the equation. So let's go ahead and take a look at figure 16 and see what we're given, what this equation is. So let me switch over to this. So here we're given this equation 179x plus 2600. And so our x is the years and the y is the debt in billions of dollars. So our first question said approximate the credit card debt in 2012. So these years 1, 2, 3, 4, 5, we have to see what information we're given to know what those represent because we don't have the year 1. And so we're told that the data are for the years 2010 to 2015. So that means that 0 is 2010, 2011, 2012, 13, 14, 15. And we want to know the credit card debt in 2012. So we want to use x equals 2 and plug it into our equation here. So if I go back to our whiteboard, we want to plug in 2 into our equation. So our equation is y equals 179.0x plus 2600. So if I go ahead and plug in x equals 2, we get y equals 179.0 times 2 plus 2600. So if we go ahead and double 179, we get y equals 358 plus 2600. And then if I add those two together, we get 2958. So this is our credit card debt. And so remember, this is in billions of dollars. So we're going to put 2958 billion, dollar symbol in the front. All right, and then for the second question here, they want us to use the graph and the equation. So we're going to do it 2 separate times to find the year when the debt was about $28 billion. So first, from the graph, $2,800 billion, if we go back to the graph here, 2,800 is right here. And if we go across here, it's a little bit past the 1. It's about right here. So we're right roughly here, follow that down. I'd say that's about 1.25. And we're approximating, so we can always round that down to 1. So around 2011, we could say month 2 of 2011, but I'll just go with 2011. So if we go back here and put the year 2011, now we want to do the same thing, but we want to use the equation. And so our equation, remember, we have y, which is the debt, and x, which is the year. We're looking for the year, so that means we're given y. So let's go ahead and plug in 2,800 in for y. So this one is using the equation. So we have 2,800 equals 179x, I'll leave the 0.0 off, plus 2,600. Now we want to solve for x, so I will subtract 2,600 from both sides. And we get 200 equals 179x. And if we divide both sides by 179, you can do this long division off to the side. I'm going to go ahead and just write down what we get. It says to round down. So what we do actually get is 1.18. But since they tell us to round down, We're going to round down to the nearest whole number. This rounds down to x equals 1, which if you remember, 1 represents 2011. So we do get the same thing. This one is a lot more accurate, but since we're talking about years, we don't really talk about 2011.18, so we're just going to leave it as 2011. All right, so then like I said, next time we'll start talking more about linear equations, slope, and all that good stuff.